Send the request. Yeah.
Yes. Okay. So yeah, we are discussing ASIC design flow and there the importance of synthesis. Okay, why we need to do synthesis? Your answer is it is converting RTL to get level netlist. So let's say if you directly write the get level netlist, why we need to do synthesis?
Then can we skip that step?
No, we cannot skip.
Okay.
Okay, see, synthesis stage, it's not only converting RTL to netlist. Okay, it is the stage where RTL is converted to technology dependent netlist. Okay,
Okay. Yeah.
RTL will never have any technology dependent. Means from
It's a
RTL will not get idea like it is what is the standard area and nothing. Okay,
Okay.
so same RTL can be used in multiple technology, and then to convert with respect to that technology, you require the synthesis. Okay. Right. So synthesis does two parts. One is technology mapping. Then it can optimize the design with respect to PPA, power, performance, and area. So let's say in specification you have mentioned that my design area should be as less as possible. So
yes, sir.
you can reduce the unwanted cells. You can reduce downside the cells. All. Okay.
Okay, sir.
Okay.
Because specification is mentioned what should be the area of chip. Okay.
Okay, sir.
So that's the purpose of synthesis.
Okay. So, sir, as you mentioned, if we do the synthesis step, then we'll get the power, area, performance. It will give you the accurate gate level netlist. So that's the reason, and it is also dependent, right? Dependent technology. So that's the reason
Yes.
we are using the synthesis step definitely.
Yes. Right.
Okay, sir.
Okay. If your chip requires very fast performance, okay, you cannot use older technology nodes, 28, 65 nanometer.
Yeah.
Then you need to go to lower nodes only, 16 nanometer, 7 nanometer.
Okay.
And I believe this technology node, right, how it is related, like how the numbers coming, like 65, then 28, then 16. And
Sir, if you don't mind, yeah, can you explain that concept
yes,
also?
okay.
Yeah.
90 nanometer is the technology because I started my journey with 90 nanometer only. I think older one was 130 or 110, but I don't remember. Then it is 65 nanometer, then 28 nanometer, then 16 nanometer. Then you will have 7 nanometer, you will have 5 nanometer, you will have 3 nanometer and 2 nanometer. Okay. Now these numbers are coming as per the Moore's law. Okay, you might have studied that transistor counts are double and all.
Yes, sir.
Okay.
Mhm.
So if you know some device physics or CMOS level or VLSI idea,
Mhm.
you will get idea.
Yes,
And
sir.
okay, basic question: what is this technology node? What do you mean by this 90 nanometer, 65 nanometer? Any idea?
So this is the size of the chip, right, sir?
No.
No.
Nanometer is very small, right? That smaller chip cannot be. Okay. Any other answer? Okay. Inside CMOS, we'll have PMOS and NMOS, right? So let's say this is your NMOS. We'll have source and drain. Between the source and drain, you will have the gate,
Yes, sir.
right?
Yeah.
Basic NMOS or PMOS. So The length, okay. This is the 28 nanometer. Let's say you are working on 28 nanometer. So this technology node is nothing but the channel length.
Okay, sir.
Okay.
Yes, so for any transistor, we are mostly majority time referring as device as well. So for any device, we'll have two important factors, W and L, width and length. Okay. So L is the channel length. Okay, I'm not going more into those
Yeah,
physics
sure, sir.
levels,
Okay, sir.
W by ratio and all, but yeah, I think you might have get idea. Okay.
Yes, sir.
Yes, sir.
So Moore's law previously it was, I mean, till following till 7 nanometer is proper. But then if you see the numbers are very near, okay, 7, 5, 3, 2, and all.
Yeah.
Okay. Then after that it is not exactly following it.
Okay.
Okay, fine. So yeah, we understood the synthesis.
Yeah.
Any idea what should be the next stage?
Physical design.
Next stage will be DFT, sir.
Right, okay. So synthesis DFT both is combined. Yeah, we can mention DFT as well.
Okay.
So any idea why we require the DFT?
I mean, we need to check all the whatever we are getting the input. So we need to check, right, sir? Is everything right, correct or not? Is there anything we are missing or like that? Design for test.
Input means which kind of input we should check?
Like we are getting right net list.
Mhm.
I mean, we need to check overall design, right, sir? After getting the output from the RTL. So we need to recheck the.
We can give it certain test cases to see how it will function after the design is manufactured.
Right. So if you don't provide this test case, or let's say if you don't do DFT, which problem you might face? Like chip will work or chip will not work?
It will work, sir, but maybe might be it will be failure, right? There is a chance
Yes.
of
Okay.
failure.
So
Yeah.
let's say if chip is not working, okay, chip is failing. Now chip will have millions of flops and all, right? Gets.
Yeah.
You will not get idea like which flop we have problem. Okay.
Yes, sir.
So to
Mhm.
identify that, there is a technique DFT design for test. Okay.
Okay, sir.
So along with your functional logic, like from where RTL it is written, you are adding some extra logic.
Mhm.
Okay. So with this extra logic, after the chip comes, let's say chip is fail, you will able to test. Okay, where chip is failing, what is the problem?
Yes, sir.
So that when you build the next chip, you will have that idea. Okay.
Okay, sir.
Right. So that's the advantage of DFT. Any disadvantage of the DFT?
Uh, what if we miss some test cases?
Yeah, one of the disadvantage of DFT is like to test your chip, right? You need to add the extra logic. Okay. If you add the extra logic, it will have area. The chip area will be increased.
Okay.
Okay, sir.
Right? Okay,
Yeah.
fine. So fourth number is a DFT. Which would be the next fifth number?
Next is floor planning.
No, it will be later. There is one step here. Okay, it is also verification. Okay.
Oh, it is also verification. Okay, sir.
If you remember, I mentioned like there are two types of verifications are there.
Yeah.
So this is second type of verification. So first verification, just after RTL, that we give proper specific terminology, functional verification.
Yes, sir.
Okay.
Yep.
Now this verification is referred as the formal verification.
Mhm.
So any idea why we need to do formal verification? We are already doing the functional verification, right?
Yes, sir. So,
It is to compare our RTL to the generated netlist.
Yes, that is right definition of formal verification. But why we need to do that? We are already checking that RTL is proper, right? RTL, let's say functional verification is done, it is passed. Then why still we need the formal verification? Okay, so answer is here only. Okay, like after RTL, we are doing some process and then only we are getting netlist, right? Get our netlist.
yeah.
So during that process, that nothing but the synthesis or DFT. It is possible that your functionality might change. Okay.
Okay, sir.
So by mistake, instead of OR get, it is added AND get. It will change the whole functionality. Okay. So that's
Okay,
why
sir.
we need to do verification, formal verification.
Okay, sir.
Now let me explain again the difference between functional verification and formal verification. Okay, let's say you are building one chip. It has only two input. Okay,
Mhm.
two input A and B, and only output one. So how you will do functional verification? You will check 0 0. You will get output. Okay, what is the output? So as you have two input, you will get all the two combination of the two. So basically today we have four combination. So you will provide all four combination. You will check whether whatever output you are getting that is right or not. Okay. So this is the formal functional verification. Okay. So in
Yes, sir.
practical chips, the input ports can be thousands of ports will be there. Okay. So just try to understand the complexity. How many combinations are required? So these combinations are nothing but the vectors. Okay, you will provide vector, and with this vector, you will check whatever output you are getting that is matching your functionality or not.
Okay, sir.
Okay. So
Yeah.
as you are giving many vectors and you are checking output, so that's why it is very longer process. Okay, functional
Okay.
verification.
Okay, sir.
Now in formal verification, you are not doing that process. Okay. So let's say formal verification, you are getting netlist, right? You will have same port. Okay. So what you will do, like see, if you know in RTL, if you are giving 0 0 input, you are getting one output. Same way in the netlist also you will give 0 0 input. You are checking what output you are getting. If output is one, that is same as the RTL, then it is pass.
Okay.
Okay.
So, okay,
If
sir.
yes, go ahead.
No, no, sir. I'm just telling this.
Okay. So if output you are getting zero, that is not matching with the RTL, right? Then your formal verification is failed.
Okay.
Okay. So that's why it is very faster method. Okay. Like you are just checking what RTL you are getting output, and same you are trying to check in the netlist. Okay. But if you are giving zero input and output should be 0 or 1, that right, that will be decided by the functional verification.
Yeah. Okay, sir.
Okay. So then this formal verification we required in every stage of the physical design. Okay. Whenever you
Okay.
change your netlist, you need to do formal verification.
Okay,
For
sir.
example, after placement, new cells will be added, few cells will be removed. So we
Mm-hmm.
should ideally we should check the formal verification after CTS route. Okay.
Mm-hmm. Okay, sir.
Okay.
Okay. So formal verification is done. Which number we give? Yeah, fifth number. Okay. So which will be the sixth number stage now? Okay, now it's come the physical design. Okay,
Okay,
floor
sir.
plan. So previously, like in older days, before floor plan, we used to refer all the stage as the front end. Okay, and floor plan and the later stage we are referring as the back end. So that's why ASIC design flow is divided into two parts. Okay, front end, back end.
Okay,
So
sir.
when you say physical design, it is the
Yes.
back end.
Okay, sir.
Okay, but nowadays the chips are getting complex and all. So physical design team only doing the synthesis.
Yeah. Yes, sir.
Okay, so but previously this was the concept like physical design will start at the floor plan only. But nowadays physical design can start from the synthesis itself.
Synthesis. Yes.
Right. So any brief idea like what we are doing in the floor plan?
Yes, sir. So usually the floor plan is a main step. So in the floor plan, we will determine the die size, core size, and aspect ratio, what is the utilization, and placing the macros in a proper placement. And also, like we will place the IO ports. So these are the main stages we will do in a floor plan. So the main thing is like we need to place the macros. We have some rules and regulations to place the macros in a proper way.
Okay, good. So yeah, I mean that's enough. Okay. Basically, in your design macros, those bigger size, right? You are placing
Yeah.
first. Okay.
Mhm.
So that's the floor plan. After floor plan, which stage will come?
So after floor plan, we'll get the power plan. So power plan is also included in the floor plan, but yeah, in power plan uh, we usually keep the straps, rails, and
If you don't do the power plan, what is the problem?
so we'll get the problem in the routing stage, and we'll get the conjunction problem also.
So you are saying if you don't do the power plan, we'll get the congestion.
I think no, sir. I think I can. So we usually get only the routing problems, sir, if we don't do the properly in a power plan.
No, what I'm saying, if you don't do power plan at all, okay,
Okay.
right? Is there any problem?
Yes, sir, we'll get a problem because
Mm-hmm.
because before the placement in the standard cells, we need to do the power plan. Without like power planning properly, then if we go to the step placement stage, then we'll get a routing problem in a routing stage. Like if we place the standard cells, then we'll get issues, right, sir? Then we can't give you the proper power to the all the standard cells, and we can't it won't get any power to all the standard cells.
Okay, so you are saying basically just to give power to the standard cell, we need to do power plan. Okay. Now,
No, sir, not only the standard cell,
Mhm.
for all the macros and
Okay.
whatever inside the chip to get the proper proper power to all the cells, macros, and whatever you're placing inside the chip to get in a correct and accurate power. So we are using the power planning.
Yes, that's true.
Yeah,
So you are saying like standard cells we are not placing in the floor plan stage. Okay.
yeah.
Then what is the importance or significance we are doing power plan?
For voltage, to avoid voltage issues in future.
Okay. Okay. Let me ask other way. So in floor plan stage, you don't know, right, where your standard cell is going to be placed. Then how will you do the power plan if you don't know where your standard cell is going to be placed? Okay. Goal of the power plan is, yeah, it should provide the power to the all the standard cells macro and all. But question is in floor plan stage, we are not placing standard cells. Then how tool will get idea like where I need to create power? Getting the question?
Yes, sir.
Okay. Let me give analogy. Let's say you are building any town, new town. Okay.
Mhm.
So it will have lots of building and all. So
Okay.
first, what you will build? Like you will directly start building those big high-rise building, or you will do anything first?
So, like, we will give some like electric and water supply. So, where we need to.
Right. Now, same question here. So you are not knowing, okay, where you are going to build the building. Then how
Yeah.
will you do the electric supply and all?
So, but we need to distribute the grid, right, sir?
Yes, this is the word, okay, distribution.
Okay.
We are doing the uniform way, okay. In the
Okay.
chip, even the new town also, we are first we will build the roads, electricity,
Mm-hmm.
and then yes, wherever space is there, you can build have the buildings, okay.
Yes.
Similar way, standard cell also, even though we are not placing, but we are creating the power plant,
Mm-hmm.
and that goal of power plant is to distribute the power uniformly. Okay,
Yeah.
so even the standard cell is placed in corner or middle, it should get ideally similar power.
Yeah. So,
Okay,
yeah.
so that's why standard cell information is not required.
Mm-hmm. Okay, sir.
Okay, good. So that is power plant. Any next stage?
Placement.
Right. Any brief idea what we are doing in placement stage?
So, in placement stage, we usually will place all the standard cells.
Okay. So that's it. Only placing standard cell is that is the goal of the placement.
Um, yes, sir. Like usually we'll place the, I mean, standard cells in a legalization way. And also we will check the without any conjunction problem. So we'll place all the in a proper
Good.
placement.
So
Yeah.
okay, so basically you will make sure that while placing the standard cells, you will not get the congestion.
Yeah, without getting any conjunction. So we need to
Right.
place the standard cells in a rows.
So let's say, yeah, I mean, in the town you build you have all the building, hospitals, police station, everything.
Yeah.
Now, what if hospital is placed out of the town?
Mm-hmm.
Yeah, you don't have congestion. That means, yeah, roads are you have built properly. But what problem you are seeing here?
More like time to reach the hospital.
Yes, good. So that try to put into the physical design placement.
Okay, sir.
Okay, see, along with the standard cell placement, you will make sure that standard cell are placed proper location. Okay, means it
Okay,
should
sir.
meet the timing.
Okay, sir.
Okay, if you have timing violation, you will do optimize your design with respect to timing. Okay,
Okay, sir.
so to optimize, yeah, you new cells might be added, few cells might be deleted, and all the optimization techniques will be there.
Okay, sir.
So placement stage is placing the standard cell plus optimization. Okay, good. So that is the placement stage. Next one.
clock tree synthesis.
Good. So why we require the CTS?
So we need to provide all the clocks to all the standard cells macros.
Yes. So basically, we'll have in our design we'll have the sequential element, flip flop, ledge, macro. So it's work on the clock, right? So
Yeah.
goal of the CTS is we need to provide the clock to all the element generally nearest time. Okay.
Yeah.
Similar time.
Mhm.
Right. Then
Then we'll get the routing stage.
so why can't we do routing first and CTS later?
So, like first we need to place a clock, then we can give the power, right, sir?
Yeah, power we are doing in the 7 number stage, right? Power plan is done. The question is why routing stage we are doing after? Why not before CTS?
Clock nets will not be defined yet.
Okay, see clock net and all right. In your SDC, you are creating the clock, create clock. Okay, so wherever that net is going, that is the clock net.
Okay.
Okay. Now, one clock port will be connected to let's say 1000